A little bit. So you've done systems of inequalities. Started that in Algebra 1. Remember, we had to graph each individual line, and we had to decide if it was a solid or a dashed line. How do you know the difference between solid and dashed? Good. If it has an equal to, we do a solid line. If it's just strictly less than or greater than, we do a dashed line. If I'm going to graph these lines, probably it's easiest to put them in y equals mx plus b form. So I can subtract over my x. So y is less than or equal to negative x plus 2. So to graph that, we have a y-intercept of 2. Slope was negative 1, so down 1 over 1. Solid or dashed? Does anyone want a ruler? You guys are good? No perfectionists in this group? What's the next thing you have to do? Shade. Remember, this line is just where y is equal to negative x plus 2. I want to know where y is less than negative x plus 2. So we have to decide where to shade. So there's two ways of doing that. When you were originally taught, you probably did test points. You had to pick a point that wasn't on the line. 0, 0 was usually the favorite point, unless it fell on the line. And you put that in. So then you would get 0 is less than or equal to 2. Is 0 less than 2? Yes, so that's true. So we shade where 0, 0 is. Now this isn't my final answer yet, so just lightly shade it in. Now, the other option, I always tell my classes, if you're just looking at a line, less than is below the line, greater than is above the line. So you could look at this and say y is less than, so y is below this line. I'm okay with that, but if you need the test point, go ahead and do so. Second one, we graph it. So first, put it in y equals mx plus b form. So that means y is greater than or equal to negative 2x plus 4. So we graph our line, y-intercept of 4. Slope was negative 2, so down 2 over 1. Solid or dashed? Solid, because equal to 4. That is a very clear line. Yours looks a little bit better. You could look at that and say greater than would be above the line, or if we do our test point, that tells us 0 is greater than or equal to 4. Is 0 greater than 4? 0 is smaller than 4, it's not greater, so this is false. So 0, 0 didn't work, so we're shading the other side of this line. Now, it's a system, so my actual answer is the overlap. So it's this region between the two lines. I have to be able to tell that apart from the rest of your shading. So some people like to go back and erase. Some people just color this in darker. Some people like to use a highlighter or something and color in their final answer. I'm okay with any of the above as long as I can tell when I look at your paper exactly what your solution is. So this is saying that little region, any ordered pair I pick in that purple area makes both inequalities true. Okay, do we kind of remember doing this? Why don't you guys try, take a look at this. Go ahead and see if you can do that. First, so when you're solving that first one, you divide by negative 2. Dividing by a negative flips our inequality. Negative x divided by negative 2 would be a positive 1/2 x minus 3. So that's the line you're graphing. So when you graph the first one, we solved it. We got y is greater than 1/2 x minus 3. Solid or a dashed line? Dashed. Y-intercept of negative 3. Slope 1/2, so up 1 over 2. Dashed line. I mean, you could look at that and say greater than means above, or you did your test point, 0, 0, you get 0 is greater than -3, which is true. So we're shading up here. The second one, when you solve for y, you get y is less than 1/2 x. So that's a line, y-intercept is 0, slope 1/2, also dashed. Can I use 0, 0 for my test point? No, because it's on the line. So pick something else. So maybe 0, -1. If I did that, I get -1 is less than 0, which is true. So that one's shading below. So my overlap is in between those two parallel lines. Is that okay? Let's look at the next one. So slightly different. Usually in the past you just did lines. We've graphed a lot of different things this year. So we could do systems of inequalities with any of those. If you're not sure what something looks like, you can always plug in points and see. So this one, the first one, might be a little bit harder. Does anyone recognize what that is? X squared plus y squared equals 9. It's been a long time. It was like October when we talked about these. Okay. If we don't remember, we can plug in points, right? Let's just pretend it was equal to 9 for a second. If you put in a 3 for your x, then you would get 3 squared plus y squared equals 9. So what's y turn out to be? 3 squared. So it'd be 3, 0 is a point on my graph. If I put in -3, -3 squared is 9, so y would again be 0. What if I plug in a 0 for my x? Then I get y squared equals 9. So y could be positive or -3. What's this turn out to be, guys? A circle. A circle with center 0, 0 and a radius of 3. Solid or dashed? Dashed because it doesn't have an equal to. Okay. There's my beautiful circle. All right. Test point. If I put in 0, 0, you get 0 is greater than 9. Is 0 greater than 9? No. So 0, 0 doesn't work. That means we're shading everything outside this circle right now. Okay, second one. This one's a line. So if we get y by itself, we get y is less than or equal to -x plus 3. So y-intercept is 3, slope is -1. That would be a solid line because it has an equal to. Less than is below this line. So my overlap is everything that is below my line, but outside the circle. Okay, so I don't only have to be looking at lines. I could be looking at any types of graphs here. Any questions on that one? Okay. Let's do a couple more. What's this first one? As x squared, what's that look like? Yeah, it's a parabola. Since x is squared and the y isn't, that's a parabola. The minus 4 moved it down 4. If you weren't sure, you could always plug in points. If you put in 0, you get negative 4. If you put in 1, you get negative 3. If you put in 2, you get 0. If you put in negative 1, you get negative 3. Negative 2 gives you 0. Solid or dashed? Dashed. Okay. If you did a test point, you get 0 is greater than negative 4, which is true. So I'm shading where 0, 0 is, which means I'm shading the inside of this parabola. Second one is a line. Y-intercept is negative 2, slope is 1, so up 1 over 1. Solid or dashed? You could know that less than is below, or if you do a test point, you get 0 is less than or equal to negative 2, which is false. So 0, 0 doesn't work, so we're shading below this line. So what's my overlap region? How are we feeling about these? Okay. Let's go to the very last example. So the last two just have situations where we have more than 2 equations. We could put as many as we wanted. And you're just looking for the overlap between all of them. Okay, so if I go to this one. If you just have x equals a number, what kind of line is that? If I said like x equals negative 4. It's a straight vertical line, right? So this is really saying we have 2 lines, x equals negative 4 and x equals 0. And we're looking at everything between them. There's no equal to, so they're both dashed. So we have this one at negative 4, this one at 0, and x is between the 2. With the next one, we solve for x. That means y is greater than negative x plus 2. So y-intercept of 2. Slope of negative 1, solid or dashed? Okay. You could say greater than's above, or if you did a test point, 0 is greater than 2 is false. So 0, 0 doesn't work, so we're shading. Last one, if I solve for y. Y is less than negative 2x plus 10. So y-intercept of 10. Slope of negative 2, so down 2 over 1. solid or dashed? Wasn't equal to his dashed line. Okay, then we just have to figure out where to choose shade. So you could say less than's below, or if you did a test point, 0 is less than 10 is false, or is true. So we are shading 0, 0, so we're below this line. So what's my overlap? It's kind of confusing when you have more. So this section of the vertical lines that's above my purple and below my orange. Just that part right there. All right. You guys think you could try homework? Okay. I have a handout.